The first thing we're going to look at are the different calculations to find distance, speed, and time of a problem. The first thing I would like you to do is pause this video and draw the circle here on the left on your notebook paper. As I go through the three different examples, I would like you to continue to pause the video and write them down in your notes. The first thing that we're going to look at the top is D represents distance, S represents speed, and T represents time. The first thing we're going to look at is how to find the distance. If you look on this circle, you're going to notice that S and T are next to each other. This means in order to find the distance, you are going to multiply speed times time. For the next one, if you look, we're going to look to find speed. Now on our circle, you're going to notice that the D is over T. So this means when we write this equation, we're going to write it as speed equals distance over or divided by time. Finally, the last one is time. Just like the last one, you're going to notice that distance is over speed. So for our equation, we're going to write time equals distance divided by speed. If it helps in your notes, you can write out the words instead of the letter, but it's whatever your preference is and whatever you need. Here's a distance time graph like the one that you saw in your quiz. A couple of things that I want to make note of before we dig a little bit deeper into this. The first thing I want you to see is that on the bottom we have our time, and in this particular example we're looking at seconds. On the left-hand side of the y-axis we have our distance, and in this example we're looking at meters. This graph shows the speed or the motion of an object. It does not necessarily tell us the direction, so we don't know if this person traveling is going north, south, left, right. We simply know the type of motion that they're doing. We learned this week 6 different types of motion: steady speed, rapid steady speed, no movement, acceleration, deceleration, and return. This graph combines several of those different types of motion. If we were to dissect this graph, the different things that we would look at is, first of all, from O to A. You'll notice that this is a straight line. It also shows that we're traveling 10 meters in about 5 seconds. This would be considered rapid steady speed. It's a steep line, and you're covering a lot of distance in a short period of time. Because it's a straight line, we know that it's some sort of steady speed. It's consistent. They're not going from slow to fast or fast to slow. It's steady the entire trip. The next line is a straight horizontal line. If you notice, the distance never changes. From point A to point B, it's always 10 meters. However, the time does change. Point A is at about 5 seconds, and point B is at 10 seconds. So this means that this person was standing for 5 seconds at 10 meters. This would be as if you were standing waiting in line somewhere. You're standing still with no movement. The next one, from B to C, is return. We're going from a distance of 10 meters to a distance of 0 meters. So we're traveling the entire 10 meters in about 3 seconds. This would also be considered a rapid speed. So even though it's going back to the beginning, this is considered return, but you also can talk about the speed. Because remember, speed is distance over time. And we're covering a lot of distance in a short period of time. Here's one that we looked at before, a horizontal line, so it means that they're just standing still for about 3 seconds. Here's another straight line. This represents steady speed as well. Notice that this line is not as steep as this line or this line. This simply means in this location, this person traveled at a steady, consistent speed, but not as fast. Finally, you wrap up the graph with the same no movement line, a horizontal line, which represents no movement.